Alright, so good morning everybody. Now let us continue with a short overview about the third Newton's law of motion. So before the third Newton's law of motion happens, we have to start from the basic concept of gravitational forces. We have the first Newton's law of motion, which refers to the law of inertia. Then the second Newton's law of motion that refers to what we call acceleration or the change of speed, including the centripetal forces and circular motion. And now, we refer to the third Newton's law of motion, in which this is related to our real life activities. Our day-to-day activities that usually takes place and enables us to understand what Newton's third law of motion is. So in this concept of Newton's third law of motion, why don't the forces in a force pair cancel each other out? So what is really a Newton's third law of motion? I'll repeat. What is a Newton's third law of motion? So this one is, it is a law that states that for every action, there is an equal and opposite reaction. So it happens in our everyday life activities. So we have few basic examples. The action there, will let the engine push forward. And what will be the reaction? The exhaust will push backward. Another example that we can relate is what we call force pair. The forces of two objects apply to each other. Between you and your friend, when you try to test your strength, your muscular strength, and try to compare your force, who among two of you, will have a higher amount of force. So it can be person 1 or person 2. It differs also with your weight or body mass index. Means to say that you are stronger than your friend, or your friend, is stronger than you. So there is always a forward and backward forces that should go against or resist against the motion. What does that mean? That in every action that you take, there is an opposite or equal reaction. If you try to go back and remember about the parallel and non-parallel forces, by getting or solving problems related to resultant forces under the first Newton's law of motion, that's what you have observed, So therefore, when an object applies a force related to opposite forces, when an object applies a force on another object, the second object applies a force of the same strength on the first object. But the force is in the opposite direction. Just take note of this. So in your action, you're trying to push your table. However, that table probably it's denser compared your weight, your body weight. So probably that second object applies, or that table applies a force of the same strength on the first object, but the force is in the opposite direction. So when these things happen, so normally, if the object, okay, like heavy bags, heavy chairs, or heavy tables, it's hard for you to push that one, if your body weight is lesser than the object that you are pushing. So of course, the object, okay, push back on you. Right? That will be a possible reaction of the force since you have a less weight or you are not heavy compared to the object that you are pushing or even pulling. So therefore, the reaction towards the object, the block pushes, okay, back to you. So literally, what is the Newton's third law of motion? Very simple. To understand, when one object applies a force on a second object, the second object applies an equal force in the opposite direction in the first object. Okay? So there are several situations that we can cite in this one, right? Related to the third Newton's law of motion. Because in every actions, especially for living organisms or non-living things, okay, once forces created, by physical body itself or our physical body, it always refers, okay, with what we call the opposite force or the opposite reactions. So therefore, according to the Newton's third law of motion, when one object applies a force on a second object, the second object applies an equal force in the opposite direction of the certain object. So say for example, if your friend, as I've said before in our previous discussion related to playing a skateboard, when you and your friend, you have the same weight, he or she has 40 or 50 kilograms, and you too, you have 40 or roughly around 50 kilograms, then you have to expect also the weight of the skateboard the same. So by the time when you are going to play in an opposite direction, this one also might be an indicator how fast or how slow you play, and how fast or how slow the skateboard is moving. So how are you going to control that one? So it depends. You are going to control yourself, your body weight, in order to slow down, since the skateboard is accelerating. So therefore, how to slow down and stop the object, especially when playing skateboard, right? You may notice that one, it might also eventually stop, or there is a certain object that triggers the skateboard to stop from slowing down. In the first place, it was accelerating, then decelerating, okay, which is slowing down and then stop. So there is an opposite force, So what is the opposite force or the reaction force, okay, taken in this situation? So by accelerating, there are factors. By decelerating or slowing down until stopping the object to move, okay, the factors there is because of the friction. So you're moving forward, along with your body, and then the frictions on the ground, okay, push also backward towards the tires of the skateboard. So a friction also will be the indicator about the opposite force that helps to resist against the skateboard or the wheel of the skateboard, right? So next one. A force pair is the force of two objects applied to each other. If the forces of a force pair always act in opposite direction, they're always of the same strength. So they do not cancel each other out because each force acts in a different object. So therefore, if you remember about the resultant force, if the two magnitudes or two forces are the same, so the resultant force will be zero. So there's nothing happens to an object. It remains at rest. Unless if there is another object or heavy or light object triggers to this situation in order that that object will move. But remember, if two forces are the same, okay, you have to expect that the object remains stationary. So it will remain at rest. So the resultant force or net force will be zero. So adding forces can only result in a net force of zero if the forces acts on the same object. So according to the Newton's third law of motion, in this equation, guys, opening the window or by opening the door, either you're going to slide to the left or to the right, or by pushing the window forward or pulling the window backward. But now we will sight into a door. Either your door has a doorknob or there's no doorknob. So when you push the door forward, the door pushes to you backward as well. We also noticed when you pull on the door, okay? So you pull the door backward, then the door pulls you back. Okay? Depends also on the weight of the door. Okay? So your force therefore is equal to the force on the door. So therefore, the action force equals to the reaction force. So therefore, adding forces can only result in a net force of zero. If the forces act on the same object, in a force pair, one force is called the action force and the other force is called the reaction force. So why don't the forces in a force pair cancel each other? They do not cancel each other out because each force acts on different object. That's mainly the reason. So to summarize in our discussion, the third Newton's law of motion describes the force pair between two objects, between you, yourself, I, myself. If I encounter this kind of situation, especially lifting object, transferring object from one place to another place, okay, literally, this is an indicator of the third Newton's law of motion. And how the object, how heavy or light the object is, might also be a factor about your body or physical body's reaction. Okay? This always happens in our everyday life activities. For every action force, there is a reaction force that is equal in strength but opposite in a certain direction. So, what are those examples that we can cite? About this one, okay, pushing a box forward, but sometimes you notice, it also depends on the surface of our floor, right? It's easier for us to push an object if the floor is shiny because of low friction. But there were times also when you push a box or heavy box forward, it's hard for us. It will resist. Why? Because the friction is high due to rough surface. Okay? So there is in every action that you take, there is always an opposite or equal reaction. Okay? So there are certain factors that we also have to consider. Okay? In this real life situation. So therefore, okay, we were able to sum up those things, in which this is how the third Newton's law of motion takes place in our day-to-day activities. This is not the only thing. There are many examples, various examples that we can cite and enumerate related to the third Newton's law of motion. Right?